Welcome back to Monroe Tutoring, or welcome for the first time. We're going to jump right in today, and we're going to do some calculations going from grams all the way over to atoms. So in my previous video, I talked about molar mass, and I did mole mass calculations. In the video before that, we talked about Avogadro's number, the definition of a mole, and we did quantity calculations. So going from like moles to atoms. Now we're going to do a multi-step problem where I'm giving you the mass of a compound, and I want to know how many atoms are contained in that. So we're going to kind of put it all together here. And so what I taught you in my dimensional analysis video is, and if you didn't see it, go check that out. We're going to take the given information and we're going to put it to the left. That's kind of the first thing that we're going to do. So we have 0.231 grams of CH4, and we're going to set up our parentheses because we're going to put in a conversion factor. Now, we are given the molar mass of methane here. We didn't have to be given it. I taught you how to do that calculation or how to figure it out in the last video. So if you don't know how to get this, because you probably won't be supplied it on the exam, so go ahead and check that the last video. But we're just going to move on. We have the molar mass. And like I told you last time, we're going to rewrite the molar mass into a conversion factor. So instead of writing it as grams per mole, I'm going to write it that 1 mole of CH4 is equal to that many grams. I'm just rewriting this because grams per mole is saying that that's how many grams are per each mole. So each mole, 1 mole, is equal to that number of grams. Now, that can be used as a conversion factor. And so we want to cancel grams, so the grams of methane have to go in the bottom, right? Whatever unit is here, it has to go here in order to cancel it out. So I'm going to take the molar mass here. I'm going to put the 16.04 grams of CH4 in the bottom. And I typically write that unit more explicitly like this. So we're going to write that in the bottom, and then the other side of the equal sign goes on top. So that's 1 mole of CH4. Close this. Grams of methane cancel with grams of methane. Now, if the question had asked for moles of methane, we'd be done, and we would just do this math. It would be this number divided by that number, and we're going to end up with the unit that's left over. But that's not what they asked for, so there's no reason to do the math now. We're just going to keep this going and open up another parenthesis. And now we kind of have a new problem. We can kind of just ignore this part because in order to cancel grams, we had to use the molar mass, right? Whenever you're dealing with moles and mass, use the molar mass. And again, you can just look at the units. If you have grams, well, you're going to need something with grams in order to cancel that out. That's the molar mass. So that was step 1. Now we have moles. Now I'm asking about atoms. So we're going now from moles to a quantity. And that's when Avogadro's number comes into play, right? So like I taught you 2 videos ago, when we're dealing with quantities, how like we're going to count the number of atoms, we're thinking of Avogadro's number. It's just like saying 1 dozen is 12 things. It's 1 mole equals Avogadro's number of things. Now, let's write out that conversion factor as well. In this case, we have moles of CH4, and this is really important to write it out properly. So I'm going to now say 1 mole of CH4 is equal to 6.022 times 10 to the 23rd. But now, what is the thing that gets written here? What's the unit of this? Can I just write atoms because that's what I want? Well, you have to look at what do we have moles of. We have moles of CH4. CH4 is a molecule, right? That's a compound. So we can't just skip to atoms. If we're saying 1 mole of methane is equal to this many, and it's going to be molecules of methane because methane is a molecule, okay? So we can't skip to the final step. We have to do whatever the mole is of, it's that many, it's Avogadro's number of that thing. So it's going to be molecules of methane. And I like to abbreviate molecules as MOLEC period, and I'm going to put methane again. So now we have another conversion factor. We can cancel out moles and we can get molecules. So let's fill in this parentheses here. And so we have moles are on the top here. So now I'm going to put the 1 mole of methane on the bottom. So 1 mole of methane is equal to Avogadro's number, 6.022 times 10 to the 23rd. and that's molecules of methane. And now moles of methane cancel with moles of methane. So we're almost there. If I was asked in the beginning how many molecules of methane are in this many grams, I'd be done, right? Because that's the last unit standing is molecules of methane. So that would be how we would calculate that. Just punch this all into the calculator and you're done. But again, they didn't ask for that. We have one more step to go. They're asking for atoms. So now we have to think. We have molecules of methane. We want atoms altogether. So you have to do a little bit of reasoning and think, okay, how many atoms are in a molecule of methane? Well, we just look at the formula. There's one carbon, right? Because there's a implied 1 here as the subscript for carbon. So there's only one carbon and there's 4 hydrogens. So there's 5 atoms in a molecule of methane here. And I'm going to write that out. I'm going to write 1 molecule of CH4, and I like to do a colon there because it's kind of a ratio. 1 molecule of methane has 5 atoms in it. And so now our final parenthesis, our final conversion factor is going to be used because now we're going to end up with the unit that we want. So our last parenthesis over here, put our bar, molecules are in the top here, so now they have to be in the bottom over here. So I'm going to put down 1 molecule of CH4, and that has 5 atoms in it. And let's see what we get. So let's punch this in. We're going to go from left to right here. I'm going to put in the 0.231. And then I don't type in the ones. I'm not going to multiply by 1. That's a waste of my time. So I'm just going to divide by the 16.04. So divide by 16.04. And now I go to the next parenthesis. This is in the numerator, so now I'm going to multiply by Avogadro's number. So it's times 6.022 times 10 to the 23rd. And then we get to our, again, I'm going to skip the 1. And we get to our last parenthesis. And there's a 5 in the top. So I'm going to multiply this by 5. Again, not going to divide by that 1. Let's hit enter and see what we get here. We have, I just realized how diagonal I went here, whatever. So we have 4.336, and there's more digits, times 10 to the 22nd. Let's look at this real quick. That has 3 sig figs, that's 4, that's 4. This is an infinitely precise number because it's just 5 atoms in 1 molecule, so that doesn't count. So we're going to have 3 sig figs. I'm going to round this over to 4.34. Let's see here. We've got equals, that's going to be 4.34 times 10 to the 22nd. And that is atoms is our final answer. Guys, if this helped, please give a like, follow, share, save this to re-review later. And if you check out my links, you can patronize me over there and help me to continue making these videos for free. So thanks again, and I'll see you guys in the next one.